Hello everyone, welcome to Ramaile Padai. Today we are going to solve a question from Unit 12 Circle that was asked at SC 2080 at Gandaki province, and the question says that in the figure two circles are intersected at points P and Q. So this point P and this point Q are the 2 points where two circles intersect. Two lines AB and CD passes to the point Q. So AB and CD passes to the point Q, so that these two angles are vertically opposite. Fine. Now in A, what is the relationship between the inscribed angles made by the same arc? It will be same. Okay. In B, if angle QAP is 25 degree and angle QCP is 2x minus 15, find the value of x. So this two QAP and QCP, these two angles are inscribed angle of arc, minor arc PQ of this circle, of the left circle. So these two angles will be equal, and equating these two values we will get the value of x. Fine. Now we need to prove that angle CPA is equals to angle BPD. Okay, we will do that. This two angle will be equal, this is vertical opposite, and this two will also be equal. It is quite easy. And in D, verify experimentally that the central angle is double of the inscribed angle standing on the same arc by making two circles having at least 3 cm radii. So this is quite easy as well. We will construct here and then prove that. And proving experimentally means that first drawing and then measuring. Okay. So now without any delay, let's start the solution. Okay. In A, what is the relation between inscribed angles made by same arc? So this will be the relation. The inscribed angles are equal. Okay. So the inscribed angles made by the same arc is equal. So this is about solution of question number A. Now moving on to question number B. Here angle QAP is equals to 25 degree and angle QCP is equals to 2x minus 15 degree. Fine. As angle QAP and angle QCP are inscribed angles of same arc PQ, angle QAP is equals to angle QCP. So our 25 degree is equals to 2x minus 15 degree, and that gives us 25 degree plus 15 degree is equals to 2x, or 2x is equals to 40 degree, or x is equals to 40 degree by 2 is equals to 20 degree. So the value of x is 20 degree. Fine. Now moving on to C, prove that angle CPA is equals to angle CPD. Here angle CPA is equals to angle CQA. Why? Since circumference angle of arc PQ. Fine. So this CPA is equals to CQA because they are based on same arc AC. Fine. Now again, these two angles BQD and BPD are equal. These two angles are equal. Why? Because they are based on same arc BD. Fine. So angle BPD is equals to angle BQD. Why? Since circumference angles of arc BD. Fine. Now angle CQA is equals to angle BQD. Why? Vertically opposite angles. Okay, let me show you by using different color. Here these two lines CD and AB intersect at Q, so that this angle will be equal to this angle. So they are vertically opposite angles. Fine. So or CQA is equals to CPA. So we will write angle CPA is equals to BQD is equals to BPD. Angle BPD. This is what it was required. Hence proved. So first of all, we say that these two angles are equal, and then these two angles are equal because they are based on same arc AC and BD, and these two angles are equal. So this angle is equals to this angle and this angle is equals to this angle. So these two angles are equal. We proved that. Fine. Now moving on to question number D. Verify experimental that central angle is double the inscribed angle standing in same arc. Okay. Here drawing two circles with central angle AOB and inscribed angle ACB that have radius more than 3 centimeter. Now measuring angle AOB and angle ACB and filling up the table. So here will be our diagram or two figures. Fine. So let's make two circles that have more than 3 centimeter radius. Okay. So this will be the first figure, and then another will be somewhere here. Okay. So this will be another figure. Fine. What we need is a central angle and an inscribed angle. I will make inscribed angle with blue. Okay. So this will be the inscribed angle. Fine. And what we have said is that the arc will be AB. I forgot to mention that. You write central angle that have radius. Now measuring and filling out table. We haven't write any arc. It is fine. It is better to write, but if you do not write, it is also fine. Now this will be C and this will be O. Okay. So this is the central angle and this is the inscribed angle. We will measure this and fill in the table. So the table will look like this. Figure number angle AOB, angle ACB, and result. Fine. So this will be the table that we will be filling our data. So we have two figures. So one figure, another figure, and here bottom of this table will be conclusion. So in figure number 1 and 2, let's measure AOB. No, first measure ACB, because measuring AOB will be quite difficult. So this ACB is 35. Yeah, it's near 35. So it is near to 34. So we will write 34 degrees. ACB of first figure is 34 degrees, and doubling that it will be 68 degrees. Okay, let me see if you can just measure this. So it should be somewhere here. Okay, 68 degrees. So it will be 68 degrees. We are clever as well. Now moving on to figure number B. This ACB is 44 degree. Okay, so this is 44 degree and central angle will be 88 degree. Let me show you if it is possible to show with compass. So it will be 88 degrees. Okay, and the result is angle AOB is equals to 2 times angle ACB. Angle AOB is equals to 2 times angle ACB. And in conclusion, what we will write is that the central angle, okay, we'll copy that. The central angle is double of the inscribed angle standing on the same arc, hence proved. So this is about solution of this question. If you have any confusion, please let me know in the comment section down below, and I will meet you in the next video. Till then, bye bye.